Hello students, in this video let's start chapter 2 of methods of applied statistics, that is regression. Now there are two types of regression, linear regression and non-linear regression. So we will learn both of them in this chapter. Now what is this regression? It is one of the technique of predicting or estimating on the basis of correlation. It is called regression analysis. It is used in almost all the scientific discipline, economists, businessmen, natural, physical and social sciences. And here we have to learn first linear regression. So in that one, linear regression means what? A line of regression will occur there. That's why it is known as a linear regression. So let's see what is line of regression. Actually, it is or is if the curve in scatter diagram, if the curve in scatter diagram is a straight line, then it is called a line of regression. A line of regression, and there is said to be a linear regression between the variables occur, right? Between the variables. Now the equation y equal to a plus byx into x is called the line of regression of y on x and is used for estimation of y for given x, where a and byx are constants. These are what? Constants. Okay. The coefficient byx of x is called the regression coefficient of y on x. Regression coefficient of y on x. Look at this. It is y is represented in terms of x. So if x is given to us, we can easily determine y. Here these a and byx are constants. And what is this byx? Byx is known as a regression coefficient of y on x. Remember this part, it's very important. This byx is what? A regression coefficient of y on x. Y on x, as such you can easily remember. Now similarly The equation x equal to a dash plus bxy into y is called the line of regression of x on y, is called the line of regression of x on y, and is used for estimation of x for given y. Here also this a dash and bxy are constants, and the coefficient bxy of y is called the regression coefficient of x on y. Now let's see these things in detail. First, line of regression of y on x is what? Y minus y bar equal to covariance between x and y upon sigma x square into x minus x bar. It is written as such. That is equivalent to, this is nothing but byx into x minus x bar. Also, line of regression of x on y is what? X minus x bar equal to covariance between x and y upon sigma y square into y minus y bar. As such, we can write the lines of regression. Remember, these are very important things. We have to solve the examples on these one. Now let's write few notes on these. So note, first note, here x bar and y bar means what? A point where means coordinates are what? The means of these variables, is the point of intersection of the two lines of regression. Second thing, the line of regression of y on x is what? Y minus y bar is equal to covariance between x and y upon sigma x square into x minus x bar. It can be written as y minus y bar equal to r into sigma y upon sigma x into x minus x bar. It can be written as such. Again, similarly, the line of regression Similarly, the line of regression of x on y is what? X minus x bar equal to covariance between x and y upon sigma y square into y minus y bar. And that is written as x minus x bar is equal to r into sigma x upon sigma y into y minus y bar. Remember, this is very important form of these lines are regression. Now here may be question in your mind, how does this can be written as such, right? Look at here, covariance of x and y upon sigma x square. You know the result of covariance of x and y. What is covariance, or what is R actually? What is R? R is covariance between x and y upon what? Sigma x into sigma y. So from this we can write covariance between x and y is what? R into sigma x sigma y. Take this denominator to left hand side. So covariance will become a product of the standard deviations with correlation coefficient. So let me put that value, R sigma x sigma y upon sigma x square. So one of the sigma x is get cancelled. So what does this? This is R into sigma y upon sigma x. The same thing I have been written here. Similarly for this, denominator is sigma y square. So one of the sigma y is get cancelled. This is the remaining part there. Fine. Now the next note is note 3. If R is equal to plus minus 1, then the regression lines R is equal to plus minus 1, then the regression lines are coincident. Regression lines are coincident, that is y minus y bar upon sigma y equal to x minus x bar upon sigma x. It will be of this form that time after simplifying. Okay. Then next note, if R equal to 0, then the lines of regression or the regression lines are perpendicular to each other. Perpendicular to each other. Now let's see the regression coefficients. What are the basic results for them? Already you know what is regression coefficients. Vxy and Vyx are the regression coefficients. So here what is Bxy is what? R into sigma x upon sigma y. That is same as covariance between x and y upon sigma y square, right? So this can be written as result of covariance is what? Now simplified form I am writing, summation n into summation xy minus summation x into summation y upon n into summation y square minus summation y whole square. Also this can be written as summation xy minus n x bar y bar upon summation y square minus n y bar square. Now this is a simplified result to determine Bxy. Similarly, Byx is what? R sigma y upon sigma x. That is covariance between x and y upon sigma x square. Okay, that is same as n into summation xy minus summation x into summation y upon n summation x square minus summation x whole square, or that is equivalent to summation xy minus n x bar y bar upon summation x square minus n x bar square. Now look at one more thing. Coefficient of correlation. R. If we take, it will be, let's take a product of bxy and byx. Okay, then what it is, this is nothing but r into sigma x upon sigma y into r into what, sigma y by sigma x. So here these terms are get cancelled. What it is, r square. So r square is what, this product. So what is r? R is what, square root of whom, these regression coefficients, square root of product of regression coefficients. This is also one of the important result, remember. Now let's solve few examples. So let me take this example first. The following data relate to the age of husband and age of wife in years at the time of marriage. So age of husband is given to us 23, 24, 25, 26, 27, and age of wife 19, 19, 20, 21, 22. Estimate age of husband in year if age of wife is what, 20 years. Now first of all, let me assume y is what, age of husband, obviously in years, and x is suppose age of wife. Now why I have been assumed it as such, that has also a reason. Look at, we have to determine age of husband when age of wife is given. So let me assume age of husband as y. If I will assume as such, age of husband is y and age of wife is x, then I must have to determine a line of regression y on x, because x is given value and y is unknown for us. Or if you are assuming them, this is x and this one y, then you need to determine a line of regression x on y. Remember, therefore y minus y bar equal to byx into x minus x bar be the line of regression of y on x we have to use, right? So now we have to determine this equation. So for that we need to determine x bar y bar and this byx. So let me, for determining byx we had already seen a result. What is byx? It is covariance between x and y upon sigma x square. So we have to determine covariance as well as sigma x square. So for that, already we have seen these things in previous chapter. So for that we have to prepare a table for this x and y series, right? So now let it be x y, then the product xy and x square is required. For this sigma x square we need x square, and this product is required for covariance, right? Now x means what, age of wife. So let me write then 19, 19, 20, 21 and what, 22. Y is what, age of husband. So it will be 23, 24, 25, 26 and what? 27. Then the product of them, this is 437, 456, this is 500, 546 and 594. Now x square means 361, 361, here 400, then again 441 and 484. Now let's do these sums. Sums are required here. Here this sum is what? 101. This is 125. I had already did these calculations. You can do on your own. Okay. This is the table. Now let's do the calculations for determining this line of regression. So here, this is about the table simply. Here n is how much? How many observations are these? 5. N is 5. So step 1 now. Step 1, let we find means first. Mean. Okay. So what is x bar? X bar is this summation x upon n, that is 101 upon 5. So it is 20.2. Again y bar is what? Summation y upon n, that is 125 upon 5, and this is what? 25. So x bar is 20.2, y bar is 25. Okay. Now step 2. Step 2, let's find variance of x. Let's find variance of x, that is sigma x square. That is what? Sigma x square. That one we need, right? So sigma x square has a result 1 upon n summation x square minus x bar square. X bar square. So we have the summation x square, this one, right? So 2047 upon 5 minus x bar square means 20.2 square, and this calculation gives us the value 1.36. Okay. Now step 3. Step 3 is what? Covariance between x and y. So covariance between x and y is what? 1 upon n summation xy minus x bar y bar. So summation xy with us upon 5 minus x bar is 20.2 and what is y bar is 25, and this simplification will gives me the value 1.6. Now step 4. Step 4, that is regression coefficient of y on x. Regression coefficient of y on x, that is byx is equal to covariance between x and y upon sigma x square, that is 1.6 upon 1.36. So it gives byx is what? 1.1765. This one. Okay. Now once we have byx, once we have x bar y bar, therefore step 5, let me call it as this as equation number, this as equation number 1. Therefore 1 implies, what does this 1? It is y minus y bar. So y minus what? 25 equal to byx with us 1.1765 into x minus 20.2, right? So if we simplify it, how does we can simplify? Y is equal to this 25 is get added to this side plus this one 1.1765 times what? X. Take the product with this, okay, minus 1.1765 into 20.2. Now this product we will subtract from 25, so we get it here. This is 1.2353 plus 1.1765 into what? X, this one. Y is equal to this part. This is a line of regression y on x here. Now step 6 says is what? This part. When age of wife is 20, what is age of husband? So put x is equal to 20 here and do the simplification. So x equal to 20 gives y is equal to 1.2353, right, plus 1.1765 into what? 20. And this one, after simplifies it, we get 24.7647. So it is approximately equal to what? 25 years. Why is this? This is the answer here. It is approximately equal to 25 years. Okay. So let's go for next example. So next example is, for a sample of firms, the correlation between the profit rate is X and growth rate is Y is 0.9. Means what? This is R is given to us. Also some additional data is given. So mean of the profit rate is 20, means X bar, and this is growth rate, means Y bar is given. Also the standard deviations are given. So let me write the given things first. First let X is what? Already it is given. So X is profit rate and Y is what? Growth rate. This is given in percentage, right? So also given that what is X bar is how much? 20, Y bar is 25, sigma X is 3, sigma Y is 5 and R 0.9. This is given to us. Now to find what we have to find, the regression equation of y on x, that is y minus y bar is equal to byx into x minus x bar, right? Now already we have some of the values, therefore y minus y bar is what? 25. That is equal to byx. Byx means what? R into, that is same as y minus y bar is equal to R into sigma y by sigma x into x minus x bar, right? So R means what? 1 to 9 into sigma y is 5 upon 3 into x minus x bar. This part, this is a constant part here. Now that is same as y minus 25. Now this part, after simplifying, we get 1.5. Look at this is 0.3 and this one gives us 1.5, right, into x minus x bar. So therefore what we get, y is equal to 25 plus 1.5, sorry, x bar we should put here. What is x bar? It is 20, right? This is 20. 1.5 into x minus 1.5 into what? 20. So this is y equal to what? 25 plus, not 25, sorry, here it will be 1.5x. This will be 30. And 25 minus 30 will be minus 5. So minus 5. This is equation of regression line on y is line of regression of y on x. Okay. Now here also we have to estimate when profit value is what? 16%. Profit value means what? X is given. So x is equal to 16%, then y is what? How much is y? That one we have to determine. So y equal to what? 1.5 into what? 16 minus 5. So this simplification is how much? This is 24 minus 5. So this is a 19. So we can say when x equal to 16%, y equal to how much? 19%. This is the answer here. Next example is that n equal to 20, summation x is 80, summation y is 40, summation x square is 1680, summation y square is 320, summation xy is 480. Now the question is that obtain the value of correlation coefficient means r and comment upon it and find the equation of line of regression x on y. So given what is n is equal to 20, summation x is 80, summation y is 40, summation x square is this, summation y square 320, summation xy is 480. Okay. Now what to find? To find what? Correlation coefficient and equation of line of regression x on y. That is, so for this let's find first x bar. X bar is what? Summation x upon n. So it is 80 upon 20, so it will be 4. What is y bar? It is summation y upon n, that is 40 by 20, so it is 2. Okay. Now sigma x square is 1 by n summation x square minus x bar square. So it will be what? 1680 upon 20 minus 4 square. So this simplification is 68. Again sigma y square is 1 by n summation y square minus y bar square. So this is 320 upon 20 minus 2 square, and this is 12. Okay. Now what about covariance between x and y? It is 1 by n summation xy minus x bar y bar. So what it is? 480 upon 20 minus 4 into what? 2. And this simplification is how much? 16. Now we have to determine r of xy is covariance between x and y upon sigma x into sigma y. So it will be covariance is how much? 16 upon sigma x is root 68, sigma y is root 12. So this gives us r is what? 0.56011. This one. Remember it. Now also equation of line of regression x on y. So what is another part, that equation of line of regression. It is x minus x bar covariance between x and y upon sigma y square, right, into y minus y bar. Okay, so what it is, x minus 4 is equal to covariance is 16 upon the sigma y square is 12 into y minus what, 2. So simplifying it, we get, this is, take this 4 on this side, do this simplification. Whole simplification will give us x is equal to 1.33 plus 1.33 times y. This is a line of regression x on y. Now let me give one example as a homework to you. Homework: for 10 observations on price will be x and supply is what, y, of a commodity we get summation x is 130, summation y is 220, summation x square is 2288, summation y square is 5506, summation xy is 3467. Now the question is that find the value of correlation coefficient, find the value of correlation coefficient, also find the equation of regression line of price on supply. Okay, so this is a homework for you. Now do this. Okay, so here I will stop for this video. In next video we will see interpretation of coefficient of regression and properties of coefficient of regression, examples on them. Thank you.